Hello everyone. In this module, let us discuss biomolecules, carbohydrates. Carbohydrates classification and structure construction of glucose. Please subscribe to my channel. Like, share and comment my videos. Carbohydrates. Plants produce a variety of substances like carbohydrates, proteins, oils, etc. Some plants produce substances with medicinal values. That means these substances are used in the manufacture of life-saving drugs. Carbohydrates are primarily produced from plants. Some of the common carbohydrates are cane sugar, glucose, starch, etc. Cane sugar is also called as sucrose. This is obtained from sugarcane plant. Starch is obtained from rice and many other plant products like potato, etc. The simple carbohydrate is glucose and its formula C6H12O6. So this can be written as C6H2O taken 6 times. Therefore the name comes here, this is carbon. Therefore carbo. This is water this is considered as water. Water means it is hydrate. So carbohydrate. Thus carbohydrate substances with general formula CnH2ON. So substances with general formula CxH2OY are carbohydrates. But there are certain substances, though having this formula, general formula, they are not considered as carbohydrates. For example, C2H2O2. This is not a carbohydrate. Not a carbohydrate. So what is this substance? CH3COOH. This is nothing but acetic acid. So there are certain substances having the general formula CnH2O taken N times or CxH2O taken Y times. They may not be carbohydrates. On the other hand, there are certain substances, though they do not have the general formula, but still they are carbohydrates. For example, C6H12O5. So C6H12O5 does not fit into the general formula, but still it is a carbohydrate. Then what are carbohydrates? So a large number of reactions of these substances. So a larger number of reactions of these substances contain specific functional groups. Thus carbohydrates, therefore carbohydrates may be defined as the optically active polyhydroxyaldehydes or polyhydroxyketones are the compounds which produce such units on hydrolysis. Some of the carbohydrates have sweet taste and hence they are called as sugars. Some carbohydrates do not have sweet taste and hence they are called as non-sugars. Examples of non-sugars are starch, cellulose. Examples of sugars are glucose, sucrose, etc. Carbohydrates are also called as saccharides. Carbohydrates are also called as saccharides. Now let us see the classification of carbohydrates. The first one is monosaccharides. So those substances are carbohydrates that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde or polyhydroxyketones are called monosaccharides. So examples of monosaccharides: glucose, fructose, ribose, etc. So all these are monosaccharides. Next one is oligosaccharides. So those carbohydrates that can give 2 to 10 monosaccharide units on hydrolysis are called oligosaccharides. So number of units of monosaccharides that can be obtained on hydrolysis, then the class of carbohydrate to which it belongs. So if the number of monosaccharide units present in the carbohydrate is 2, then it is referred as disaccharide. If 3 units are there, it is referred as trisaccharide. In this, disaccharides are most important. Some of the examples of disaccharides, sucrose. Sucrose is obtained from cane sugar. Maltose is obtained from barley, etc. And lactose. Next one is lactose. Lactose is obtained from milk. So disaccharides may be made of 2 monosaccharides of the same type or maybe different type. For example, sucrose is nothing but cane sugar, is made of glucose and fructose. That is, sucrose is made of one molecule of glucose and 1 molecule of fructose. Similarly, maltose is made of 2 molecules of glucose. Next class of carbohydrates, polysaccharides. So polysaccharides are those carbohydrates which on hydrolysis gives a large number of monosaccharides. Examples of polysaccharides: starch, cellulose, glycogen. So examples of polysaccharides are starch, cellulose, glycogen, etc. So monosaccharides are classified to further extent. Monosaccharides are classified to further extent. For example, carbon atoms, if 3 carbon atoms are there, it is referred as triose. So therefore, if it has aldehyde group, aldo triose, or if it has a keto group, it is called keto triose. If the number of carbon atoms are 4, this is aldo tetrose, and if keto group is there, it is called keto tetrose. If 5 carbon atoms are there, aldo pentose, keto pentose. If 6 carbon atoms are there, aldo hexose, keto hexose. Like that, the classification of monosaccharides and hence the classification of carbohydrates. Now let us discuss how the structure of glucose arrived by discussing the different reactions. Structure of glucose was found as C6H12O6 by various experiments. Now prolonged heating with HI. Here prolonged means continuous heating for longer time. And we get what happens here. This is CHO. So this is a approximate structure after reacting with hydrogen iodide plus. So HI, this is heating, and we get, so this is N-hexane. Therefore, continuous heating with HI results in N-hexane. So what is N-hexane? All 6 carbon atoms in hexane are present in single chain. So this reaction tells us that all the 6 carbon atoms in glucose are present in single chain, because we are getting N-hexane. Therefore, in glucose also 6 carbon atoms must be present in single chain. Now glucose reacts with hydroxylamine to form an oxide. What is hydroxylamine? Hydroxylamine means NH2OH. What is oxime? NOH. That means this nitrogen is bonded with the carbon atom by double bond, and on the other side it has OH. This is known as oxime. Therefore, so when glucose reacts with hydroxylamine, we get an oxime. Therefore, this is oxime group. Say, what happens if a carbonyl group combines with oxide? So this is C double bond O. This is carbonyl group plus this is hydroxylamine. Therefore, here these two removed as water. Therefore, we get C double bond N OH. So this group, therefore this group forms here. Therefore, this is oxime of glucose. Glucose reacts with one molecule of hydrogen cyanide to form cyanohydrate. First of all, what is this reaction? Let us try to understand. So this is a carbonyl group. This is hydrogen cyanide, H plus Cl minus. So this bond shifts here. So this hydrogen attacks this oxygen atom. This nucleophile attacks on carbon atom. Right. Therefore, we get C OH. This is Cl. As cyanide group and hydroxy group are present on the same carbon atom, this is known as cyanohydrin. Therefore, in glucose also CHO, CHOH. So here, just like the above reaction, glucose also reacts with one molecule of hydrogen cyanide and we get the cyanohydrin. This reaction indicates, since the glucose reacts with only one molecule of cyanohydrin, it indicates that the glucose has one carbonyl carbon. So this is carbonyl carbon. Glucose gets oxidized to 6 carbon atom carbonic acid with a mild oxidizing agent like bromine water. Therefore, the reaction is in the presence of bromine water. So when glucose reacts with bromine water, we get a carboxylic acid group with 6 carbon atoms. So this carboxylic acid group, the formation of carboxylic acid indicates that presence of the carbonyl group present must be aldehyde. If ketone group is present, the long chain carbon breaks and of course we do not get 6 carbon atom carbonic acid. So therefore if carbonyl group is a keto group, then acid formed does not have 6 carbon atoms, but the number of carbon atoms is less than 6. So this indicates, since the 6 carbon carbonic acid is formed, it must be the carbonyl group must be aldehyde group. Acetylation of glucose gives pentaestate product. Acetylation of glucose gives pentaestate. First of all, let us try to understand what is acetylation. Acetylation means adding acetyl group. This is C2H5OH. This is ethyl alcohol plus CH3 C double bond O, CH3 C double bond O, CO. This is acetic anhydride. Acetic anhydride. So we get, what do we get here? So when alcohol reacts with acetic anhydride, we are getting acetate. So this is acetate. This group is called acetate. Now when glucose combines with acetic anhydride, we are getting pentaestate. That means this type of units we are getting 5, which means glucose has 5 hydroxy groups. Therefore, CHO. So, when glucose combines with acetic anhydride, we are getting a pentaestate. See, 4 acetate units are there and this is 1 unit. Therefore, it is a pentacetate. On oxidation with nitric acid, both glucose and gluconic acid give dicarboxylic acid, that is saccaric acid. Now, let us try to understand this by writing the equation. So, this is, so in the presence of nitric acid, we get oxidation. So, this is saccaric acid. And this is dicarboxylic acid. Dicarboxylic acid means 2 carboxy. This is 1, this is 1. 2 carboxy groups are there. Therefore, this is a dicarboxylic acid. On the other hand, this is a gluconic acid. This is gluconic acid. So both glucose and gluconic acid gives dicarboxylic acid. This indicates it has a primary alcohol. So this is primary alcohol. Primary alcohol only oxidizes to carboxy group. The exact spatial arrangement of different OH groups was given by Fischer after studying many other properties. Therefore, its configuration is correctly represented in structure 1. So, this is the structure of the glucose. And structure 2, this is the gluconic acid. And this is saccaric acid. Therefore, Fischer gave the correct arrangement of glucose, correct arrangement of OH groups of glucose after studying many other reactions. So this is glucose, gluconic acid, and this is saccaric acid. So glucose, structure 1 glucose, structure 2 represents gluconic acid, structure 3 represents saccaric acid. In the next module, let us discuss the cyclic structure of glucose and other carbohydrates. Please subscribe to my channel, like, share and comment. Thank you.